Welcome to Knowledge Share channel. Today in this video we will be discussing about OPAMP, and we will be discussing about some applications, how it can be used as an inverting amplifier and how it can be used as a non-inverting amplifier. And yes, you know, the full form of OPAMP is nothing but operational amplifier. So since it was used in amplification applications, in majority of the amplification applications, it is called as operational amplifier. So, but it's been used in many other applications like building clippers, clampers, wave shaping circuits, and countless applications are there. Initially, since it was found or invented for amplification application, it is called as OPAMP. So let's discuss about in this video about how OPAMP can be used as an operational amplifier. Yes, you know that OPAMP is having high voltage gain. OPAMP is having high voltage gain. That is the main advantage of it. And it will be having negative feedback. Okay, so for all the amplification applications, we will be providing the negative feedback, whereas for oscillator applications, we will be providing the positive feedback. So those are all the basics which is known to everyone. So initially, to start with, that is any amplifier will be having a negative feedback. So why we are giving negative feedback is because it has good stability. The voltage stability is good, and it can follow the changes in voltage easily if we give the negative feedback. Whereas in case of positive feedback, it is not possible to amplify to certain range, or it may go to some unstable conditions. So normally for amplification applications, we use negative feedback. So there are two types of negative feedback. So one is called as a inverting amplifier, the other one is called as a non-inverting amplifier. What it means actually? So inverting amplifier in the sense, for example, if the feedback signal is given to the negative, that is the negative pin of the op-amp, then it is called as inverting amplifier. If the feedback is given to the positive, then it is called as a non-inverting amplifier. Okay. So let's go and discuss. Okay, so for example, in case of the inverting amplifier, you will be having a gain of inverting. Okay, that is the gain. That is, you will be having, for example, if I am giving the positive input, you will be getting the negative output. That is, the gain will be inverted. Okay, so that is, it will be with the opposite polarity. That is called as inverted gain. Whereas in case of the non-inverting amplifier, we will be getting a non-inverting gain. Okay, so that is, for example, whatever value of voltage I am giving, the magnitude, it will be amplified with the same polarity. That is called as non-inverting gain. Okay, whereas in case of inverting gain, the voltage polarity will be reversed in the output. So let's discuss about inverting amplifier. So here you can see, so this is the circuit of the inverting amplifier. So you can see that the signal, so this is the signal which has to be amplified, that is Vi has to be amplified. So Vi is given through R1 to negative of the op-amp, whereas positive is grounded here. And you can see that the feedback is given again to the negative, pin, is it right? Whereas positive pin is grounded. And similarly, the plus V and minus V has been given. Okay, so this feedback resistance is R. Okay, so how you can see that when the input is given to negative terminal, it is called as the inverting amplifier. Okay, so R1 is the resistance, that is called as the input resistance, whereas here this is R2, that is the feedback resistance is something but R2. So you can see that positive is connected to ground, and because of which, so since this is an inverting amplifier, you will be getting the output phase shifted by 180 degree. Okay, there will be a phase shift of 180 degree between the input and output. So the voltage gain of the inverting amplifier, there is a big derivation. You can refer the books, and it is given by minus R2 by R1. So here I have not marked actually. There is the feedback resistance is R2, whereas the input resistance is R1. So for example, if I am giving the feedback resistance as 10 ohms and input resistance as 1 ohms, then whatever voltage, and if you are giving 1 volt, the output will be multiplied by 10. Okay, because R2 by R1 is nothing but 10, which is called as voltage gain. So voltage gain will be 10. So if I give 1 voltage, the output voltage will be 10 volt. So that is called as amplification. So whatever input voltage that will be multiplied by gain times, and that will be getting is the output. But the thing is, in case of inverting amplifier, you will be getting minus 10. That is 180 degree phase shift will be there. Your polarity will be changed. That is called as a inverting amplifier. So here you can see that the output voltage is greater than the input voltage. That's why it is called as an amplifier. Is it clear? So hope you are clear. So next we will move on with the non-inverting amplifier. So from the name itself you can understand what do you mean by non-inverting amplifier is I am going to give the signal to the positive pin, okay, whereas the negative pin is given through R1, okay, through R1 it has been grounded. So feedback is always given to the negative pin, whereas the signal is given to the positive pin, okay, whereas in previous case the signal was given to the negative pin. In this case the signal is given to the positive pin. Feedback is always given to the negative pin in order to get the better voltage stability. So you will be getting the negative feedback, and because of which the voltage stability is good. Okay, so the input is applied to the positive, so that's why it is called as the non-inverting amplifier. Okay, so here you can see that R1 is grounded. R1 is in previous case it was the input resistance. Here it is grounded, and the main advantage of this non-inverting amplifier is that is there is no phase shift. PS, I have written it as PS, so there is no phase shift between the input and output. So for example, if I am giving 1 volt as input, and if R2 by R1, if the voltage gain is 10, the output voltage will be exactly 10 volts. Whereas in previous case, in case of the inverting amplifier, it will be minus 10 volt, because you will be getting the inverting gain, whereas here will be getting the same gain. Okay, so here again through derivations you will be you can refer the books, and you will be getting the formula as the voltage gain will be given by 1 plus R2 by R1 is the voltage gain. So from this you can understand that always the voltage gain of the non-inverting amplifier is greater than 1 for the equivalent inverting amplifier. For example, if the same circuit, if we give the inverting amplifier and if you use a non-inverting amplifier, and if the same circuit is used, means for example, if the inverting amplifier is having the voltage gain of 10, then non-inverting amplifier will be having the voltage gain of 11. That is 10 plus 1 equal to 11. So that's what. So always it will be greater than 1. Okay, so the voltage gain will be always greater than 1 when compared to the inverting amplifier. So here, whereas in case of previous case, you know that the voltage gain was given as minus R2 by R1. Here the voltage gain AV is given by 1 plus R2 by R1. It's the very important formula. So easily you can identify. So R2 by R1 you can find. So 1 plus R2 by R1 is the voltage gain. For example, if I am giving 1 volt as input here, and if 1 plus R2 by R1 is equal to 10, if you are getting the value is 10, then the output voltage will be exactly 10 times multiplied by the input voltage. So since the input voltage is 1 volt, the output voltage will be 10 volt. So there will be no polarity reversal in case of the non-inverting amplifier, whereas in case of the inverting amplifier, the polarity reversal will be there, that is the phase shift will be there. Okay. So this non-inverting amplifier will be mainly used in the applications of voltage follower. So here I have written as VF, voltage follower. Why I have mentioned this is because voltage follower is the one which is most frequently used in many of the electronic circuits, and also it is used as buffer amplifier. So in order to use this non-inverting amplifier as a voltage follower, what you have to do is you have to make this R2 equal to R1 equal to 0. So if you just put both the R2 and R1 as equal to 0, then you will see that the voltage gain will be equal to 1. So from this, by this you can use the non-inverting amplifier can be used as a voltage follower. Okay, so here also it can be used as a buffer amplifier. So where you can connect the high input resistance to the low output resistance. So there are many cases where we want to connect a circuit which is having high input resistance to a circuit which is having low output resistance. Okay, so it's very difficult to connect those because the circuit will behave in a very different way, and the characteristics will be quite drastically changed because of connecting the high input resistance based circuit to the low output resistance based circuit. So in order to do that, we will be using it as a buffer amplifier and voltage follower. Okay. Thank you.